Hello and welcome to my YouTube channel. My name is Kabir, and let's get started with the episode 4 of Solidworks with Kabir. In this episode, we are going to design a vertical axis wind turbine (VAWT) using Solidworks. So don't forget to like, comment, and subscribe, and follow me on Instagram at the rate Kabir8.24. So in a vertical axis wind turbine, there are three major parts. Number one is the base of the turbine. Number two is the main pool, and number three is the blade assembly, which is the most complex one. Now just go onto the Chrome, just go onto Google and type NACA 0018, which is the airfoil type, the airfoil blade type we are going to use. Click on the first link and just click on the source that file. Copy all of these coordinates using Ctrl C. Go to Excel, Ctrl V, paste, and these are X and Y coordinates, and we are going to make all the Z coordinates to be 0. So just make all the Z coordinates to be 0. Okay, Ctrl V. Yeah. Now it is very important to save this file as a text file. Okay, so save it conveniently and as a text file. Okay, and give it some name, NACA 0018. Yes, and yes. Okay, that's done. Now let's get into SolidWorks and open the part file, go to curves and curves through XYZ points. Browse, get into that document, open that Excel file that we created earlier. Open. Okay, now click on that magnifying glass, zoom to fit. Yes, perfect. Now just convert entities into the front plane, and now we have created this curve using those coordinates. This is the airfoil design curve, and this is the most efficient curve for a wind turbine or a windmill, whatever you want to say. Now this curve although is not complete, so we are going to this is already a converging design, so we are just extending the lines so that they eventually meet at one point. Exactly. Yes, use trim entities, power trim. Just hold on the left click button and just cut through it. Now our curve is complete. Just choose a construction line and make it go through the absolute center of this curve, this airfoil curve. Yes, just connect all those midpoints. Perfect. Now as in standard, this construction line is of 1.01 millimeters. Now so we are going to scale this up to 125 millimeters. So just scale, click on the scale and move entities, select the whole curve and put the value as 125. Smart dimensions, because that was 1.01, so 125 times is 126. Change it to 125. Voila. So just randomly create a circle. Okay, and using smart dimension, put its dimensions to be around 540, which is 270 into 2, 540 millimeters. Remember, all the dimensions are in millimeters. Yes. Now click on this endpoint, control, and then on the circle. Now use the coincident tab button and properties. Same with the other end. Select this point, control, circle, coincident again. Yes, everything is done. Now we want 3 of these blades, so just select this airfoil curve, entities to pattern, select this curve, the whole of this curve. Yes. Okay, perfect. And then in the parameters, select it around to be at the around the center of this curve. Yes. Yes. Now by default it is 4. Let's make these curves to be 3 in number. Yes, done. Now we are about to extrude, but these curves are not perfect, so let's use trim again. Hold power trim, hold the left click button and just drag through it. Again, same with this one, and same with this one. Perfect. Extrude boss base, select all the 3 blades. And make the length of these blades to be around 0.66 meters, which is 660 centimeters, which is 66 centimeters or 660 millimeters. Perfect. So now we have the 3 blades, and let's go on to make the frame which will hold all of these blades. So using reference geometry, create a plane at one of the faces in the middle of, by selecting both the faces of the blade, and you will get a plane in the exact middle of that blade. Select that plane and sketch on it. Again, make a line which will symmetrically divide the whole curve with going through the midpoints. Perfect. A circle on the midpoint of this line. Yes. The diameter is 10, so the radius is 5 exactly. Now again we are going to use the circular sketch pattern option, and we are going to, around this point we want 3 circles. So as parameter we have selected this point, and we are going to select the circle. We want three of these circles. Perfect. And let's extrude them. Okay, so by default it is in the blind setting. Let's select all of those circles. Now the extrusion setting is blind, and we don't want that. We want it to be in the mid plane. So click on the drop down, select mid plane option, and let the distance to be 700 millimeters. Perfect. Now all of these blades have extensions to connect to the frame. Click on the let's again create one more plane. Click on reference geometry, create a plane on the face of one of those extensions. Expand that plane so that it covers all the 3 blades. Okay, perfect. Sketch on that plane. Create a circle. We want the circle to connect, go through all of these points, all of these all the 3 of these blades. Okay, but it is tough to position the center of that circle, so we are just going through it. So yeah, we have put up a circle. We have randomly put up a circle, and then the dimension of it is again of course going to be 540 as earlier. Perfect. Control we have done the same thing as earlier. We have selected one of the points and then control and then the circle, then making it coincident. Now we are making one more circle through the circle, one more circle through the center of the circle, and then the other one. Yes, perfect. Now let's give them dimensions. So the outer circle should be 70 millimeters and the inner circle is going to be 21 millimeters. Done. Now let's use a construction line to connect the centers of these circles. Okay, but we are going to offset them, so let's not make them for construction and make them normal lines. Done. And now using offset entities, make it bidirectional and make an end cap using an arc. Right. So we have got one arm of the frame and we have got one blade connected. Again, we are using circular sketch pattern, and we are going to pattern this arm so that it connects all the 3 blades. So in entities to pattern, we are selecting all the components of this arm. And the parameter is the circle, but we don't want 4, we want 3. Perfect. Green deck. Now again we are going to use power trim. Just hold on the left click button and just hold on the left click and cut through all of these extra lines. Perfect. Let's just remove all of these extra lines. Simple, just keep on holding the left click and go through all of these lines. Be very careful, we don't want to delete that circle. Slowly and steadily. Perfect. Now just connect the arm with the circles. Yes. Okay, so all the arms are connected. Now we have the frame ready. Just the sketch is ready. Let's extrude this frame. We have to change the length of it, the height of it. Let's make it around 10 millimeters to 20 millimeters. I think 20 millimeters is going to be fine. That's it. Perfect. Now we don't have to go through that hassle again. We want the same frame on the other side too. So we are going to use the mirror feature. So just click on mirror. The plane is going to be plane 4, which passes through the absolute middle of the plates. And the features to mirror are simply the frame, the extrude. Okay, perfect. So our blade assembly is ready. Now let's get started with the pole. It is going to be a very simple design. Just get into the part option of Solidworks, select the top plane, sketch, circle, draw a random circle, use smart dimensions, give it a dimension of around 21. Perfect. And then extrude it. Now let's make this wind turbine to around 6 feet of height, but I think that's a bit too much for the design. So let's make it 150 centimeters, which is around 5 feet. Yes, perfect. And let's give it a top head. So right click, sketch, space bar, and go perpendicular to it. Yes. Circle, use the same circle, same center point, and voila. And then smart dimension, make it around 55. Green tech, features, extrude boss base, again 20 millimeters. Perfect. That looks about fine. So the pole is ready, the main pole is ready. Now let's get started with the base. So as you can see, I have changed the dimensions to inches, right? IPS, because the drawing I had had all the dimensions in IPS in inches. So you can always change it later on. So let's get started with this. Make it a square of 4 inches of sides. Let's give a fillet of 0.25 at all the 4 sides. .25 inches. Perfect. Now just extrude this. Okay, around 0.35 inches. So now we have this initial base block, right? Now we are going to create a loft. So for that we need to create a plane parallel to this, parallel to the top surface of this block, around 0.5 inches above the block. Okay, green type. Select this plane, sketch, space bar, go perpendicular, use the circle, select the center. So using the midpoints that of the square. Yes, we have got this absolute center of this square. Now draw a circle, put in the dimensions. Let's try again. I think the dimensions went berserk. Finding the center. Yes. The dia is 2 inches. Getting out of the sketch, selecting the top surface of the block. Again, going into sketch, using spacebar, going perpendicular, making a circle just below the previously drawn circle, making its dia to be around 3.25 inches. Yes, and then coming out of this sketch, now just heading off to creating a loft. So going into the features tab and lofted boss base, select both the circles simply. Okay, this looks about right. Green tech. Now let's create some holes for the okay, so first of all we are creating a hole, so where the main pole can be fixed. Yes, making a circle on this loft. Its dia is going to be around 1.5 inches. Green tech, extrude cut, and its depth is going to be around 0.5 inches. That's about right. So this is the place where the main pole is going to stand. Now selecting the front surface of the block, let's create holes for the bolts to go, so that this base could be mounted onto a floor. Just create a circle randomly using smart dimension. Give it a dia of around 0.25 inches. Giving it a proper location, 0.5 inches from the right side. And 0.5 inches from the top side. Perfect. Just extrude cut, and the hole has been cut. Now using circular pattern, just pattern this feature, select this feature, and the direction should be one of those circles. Yes, one of these circles. Perfect. So this shows 3. Let's make it 4 and green tick. So now we have 4 holes in which the nails could be placed, or the proper mounting could be done. Nails or rivets or anything else, any fastener you want to use. Let's make it a bit more aesthetic and save some metal. So just pick up a middle point of a side and make a circle, extrude cut, make it as mid plane, right, and just cut through both the sides, yes, top and the bottom. Exactly. Now again we are going to circular pattern it. Pattern this feature. We want this on all the 4 sides. Perfect. Aesthetic and functional. Exactly what we wanted. And let's change all the dimensions to millimeters again. I later on realized that I made a mistake, which was that the diameter of the pole is 21 millimeters, while this dia is 38 millimeters, so the pole might not fix properly. So let's change it back. Change this dia to 21 millimeters. Select the sketch and edit. Select the dimension, double click on the dimension, make it 21, and come out of the sketch. Perfect. Now this will properly fit, snugly fit our pole. Now it's time for the final assembly, and just go into the assembly feature of Solidworks. All the 3 major parts are there. They've all been properly designed. We have imported all of them here. The main pole, the base, the frame, the blade frame assembly, and this is one of the frames, but I think in this assembly it is not useful, so let's delete it. Let's fix the blade. Let's fix the base. Select the base of it and the base of the pole. Coincident, green tick. But this is not going to work because the pole is by default set as fixed. So let's change it from fixed to floating, and now since it is floating, now we have to apply the mate again. Again, coincident, type standard mate, base of the base and the face of the main pole. Now this looks about right, green tick, but there is this problem because it is not concentric with that circle, right? So let's make it concentric. select the CSA of the pole and CSA of the base and make it concentric. So this is perfect, exactly as you want it. Using rotate component from the move component drop down, just rotate the frame blade assembly, move the frame, okay. Let's get started with assembling it. Go into the mate tab, select the circle over here, the CSA of the pole, but this is not the final output as desired, so we will be required to put a distance mate, because this is moving right now. We don't want that, we have to fix it. So we are going to use the distance standard mate, make it a 1 millimeter distance, face of the frame and the base of the top head, 1 millimeter distance. Now it is fixed. Green tag. So the vertical axis wind turbine or windmill is ready now. Let's do a motion study and put in a motor over here, which will be working as the outside wind. Select the component direction, that circle, okay, perfect. Green tick, play, perfect. So our wind turbine is working perfectly. Let's see it from a different angle. Yes, works like a charm. Thank you so much. Please like, comment and subscribe, and stay tuned for the next video from Solidworks with Kabir.